used to represent something like if-else statement. Okay, if-else statement. So when you have a scenario that you want, it's like, for example, where you want to have information to be entered by the customer, maybe a name, address is important, handphone number is important, but let's say other information, the one which normally when we fill out the form, optional part, where we have optional part that must or is actually, it's up to the customer whether they need to fill out, they want to fill out or not. Okay, optional part. So in order for you to do that in your Z schema, you can use what we call as set comprehension. Okay, but in this statement, because we haven't done Z declaration and so on, I will use as mathematical notation here to make you understand how to use the set comprehension first. Okay, for set comprehension, okay, actually the simple form is the one that you use in your tutorial. Okay, the simple form that you have done in your tutorial is actually consists of two parts only. Okay, the simple form. So the first part here, okay, the first part is what we call as declaration, variable declaration. Okay, so this is the part, the first part here. Then you have the bar, and then the second part is the predicate part, or sometimes can be constraints, can be function. Normally, if you have bar, okay, if you have bar like this, the second part will be more on the constraint. Okay, the condition, the constraint or the condition. Okay, so the simple form is like this. So what you have done in the tutorial, you check on the variable declaration, and then from this variable declaration, then you look at the constraints that you have in your second part there. Then you produce the result for that. Okay, you produce the result for that. That is what actually you have done in your tutorial. So same thing like this. If you want to represent the number, natural number less than 20, okay, so you can put x of type n, where normally bar we call as where, we say as where x less than 20. Okay, so this statement is to show this statement. Okay, so x is of type n, where x less than 20. So meaning that x now will be 0, 1, 2, 3 until 19 only. So that is x. Okay, so the answer will be x equal, curly braces, 0, 1, 2 and so on until 19. That's how you write the answer. Okay, so that is a simple form, the one that you are doing in your tutorial last week also. That is what we call as simple form. Okay, you may have also, that one is a constraint or condition. You may have also a scenario where also simple form, but you don't have condition. You don't have condition like x less than 20 just now. You don't have condition. You just want to show what you are going to do with x. So it's a function operation. So rather than you use bar, then you change to a big circle here. Big dot, big dot here. So big circle here, big dot here. So the second part will be function, not condition anymore, not constraint anymore. Okay, for example, I want to show that the square of x is actually x squared like this. So you just write like this. So we don't have minimum, we don't have maximum value. We just say that the square is actually any square of the x. If x is 2, 2 power 2. Okay, if x is 6, 6 power 2 and so on. So we just want to say that, but we don't have minimum and maximum value. There is no condition of minimum and maximum value. So if you have only function, you just put a dot here, big dot here lah. Okay, so rather than bar, just now bar normally will be for condition. But if it is a big dot, this is a function. So it's either the simple form, it's either just now with bar or this one. But normally in our schema later, we are not going to have simple form like this. So normally we are going to go for a combination of these two together. Okay, for our schema normally we don't have a simple form like this now. We are going to have a combination of these two forms together. Okay, so the general form normally we call as signature. Actually, the part here is signature, is the declaration part lah, easier to say. Then your condition, then your function. Okay, so the arrangement is like that. Okay, so you have the declaration, bar, your condition, then you have a big circle, then your operation then. So your operation later will be whether you want to update the customer information, or you want to add customer, or you want to remove customer, for example. All those are the operation that you are going to do later. Okay, but the condition is if there exists or not exists, whatever are. So those are the conditions that you are going to do later. Okay, so normally for our system, we are going to go for this combination of two forms, not a single form just now. Okay, so the first part here normally I will call declaration part, like easier, like programming style. We call this as declaration part, variable declaration. Then you put the bar. This is the condition part, your constraint, your condition. Okay, then you put the circle. This is the operation part. Normally I will say as operation rather than function lah. I will say as operation part. Okay, so there are general terms that they will give to us, but for your understanding, okay, if you are referring to the make it similar terms, okay, I will say this is the declaration part, this is the condition part, this is the operation part. Okay, because later we are going to use the similar terms to make it you understand clearly. Okay, so this is the declaration part, the condition part, and the operation part. Okay, so this is example because I don't have if I show you using the Z schema, most probably you will be confused because you haven't learned a lot of things yet. So here I just use a simple mathematical notation to understand the concept first. Okay, so this is how you do it lah. For example, just now we combine the square and the condition just now where x is less than 20, x power 2 means that the data of x will be 0 power 2, 1 power 2, 2 power 2, 3 power 2, and so on. Okay, until 19 power 2. That is your that's your answer lah. Okay, so 0, 1, 4, all those things, that is your answer. Okay, for your x here. Okay, so you may see also later there exists, but this one is another chapter. You have learned also about there exists. If let's say you want to use modulus, you can use modulus also. Okay, to find the remainder of your data. Okay, and then this one is actually x. X is the condition, is only x. So means that actually this one, if x is 1, then 10 times 1. If x is 2, then 2 times 10, like that lah. Okay, so it's times 10. So this is actually another example. And then you can have also something like conjunction and so on. This one, the way to write like this is going to be similar way of where you are going to write your Z schema later. Where you may have union, you may have conjunction, all those things. Okay, but you are not going to use simple like this. But you are going to go something like this later. But not number, more on variable later. Okay, more on your variable, not number. Okay, so this is set comprehension. So for our Z schema, most of us, if we go for set comprehension, you are going to use combination of those two. The combination of those two forms. Okay? So where to use set comprehension? Just now, like I told you, if let's say you have a condition like optional data that you don't want, you want to check whether the customer enter or not the optional data. If no data insert by the customer, then the data will remain with the same data, original data. But if the data is actually inserted by the customer, then you have to update the database with the data inserted by the customer. So if you want to have something like this, similar like if-else statement. Okay, set comprehension normally used to show something like if-else statement inside your Z schema. You will have this, okay, but this is actually this is the style to use for if-else statement. But some of you sometimes comes to me, can I use other way or not? So actually there is another way to show if-else statement other than set comprehension. Okay, but set comprehension is to use or to show something like if-else statement in our system later. Okay, so that is set comprehension. So you may also use quantifiers. Okay, there exists and also for all. For all, normally you use in your state space schema later in your module. Okay, whereas there exists, you will use for checking. Let's say if there exists data entered by the customer, you do this. Okay, so if there exists the data, then you do this. So it's like for if-else statement. So normally this one, for there exists, you will see in the operation schema, whereas for all, you will use normally inside nesting space. Okay, so we use there exists or for all quantifiers. This is for all together with the set comprehension just now. Okay, together with the set comprehension. So if you use set comprehension, if you want to check for all your data, then you go for all. Okay, for all. Okay, these are the symbol for all. Okay, the box here you don't have to follow. Just that the way that you write set comprehension just now, just you put for all or there exists symbol only in front. Okay, so there exists is this symbol. You have seen also there exists. So that there exists normally, okay, you use especially for the forms like that. Because you want, if there exists the data entered by the customer, you do this. Okay, if there exists entered here, you do this. So something like that, you use there exists symbol. Okay, also you can use as these are also like there exists. So normally you will see together with the set comprehension. Okay, when you use there exists or quantifier lah. Okay, quantifier you use together with the set comprehension. Okay, so it's together lah. You don't use for, normally you don't use for all or there exists individually like that. Most of the time, you are going to use with set comprehension in our schema. Okay, so that for all, this is the there exists. Okay, so this symbol you can actually use later when you go for your set schema. Sometimes you want to use existential quantifier. Also, you can use if let's say you want to check in terms of unique data. Okay, so this one you can use there exists with 1 here. Okay, the symbol is 1 here. So this is what we call as existential quantifier. So it's something like very unique data that you want to check. Rather than you use a normal there exists, then you can use existential quantifier. E1 lah, there's 1 here. 1 here means unique value. Okay, 1 means unique value. Okay? So now, how to declare your variable? Okay, so every Z schema, okay, every Z schema, when you want to declare variable, there is a type. Same like you write programming, whether it is integer, double, string, those are the type. Okay, same case for Z schema, we are going to use type also. Okay, so we have 3 different type. Okay, so whatever set that you are going to use, we have 3 different type actually used in our Z schema. So built-in, free type, and also basic type. Okay, so the one originally for set, okay, the most popular will be basic type. Okay, so built-in. Built-in is the one that you have seen before, Z and N only. Okay, so Z and N, you can simply use it. No need for you to define what is Z, what is N. You can simply use it in your Z schema. So when you simply use use it, we call that as built-in. Okay, built-in type. So only Z and N are built-in type for our schema. Okay, so you don't need to show to tell others what is Z, what is N. No need. You can straight away use Z or N. Then when I see Z, when other people see N, we know that is the number, that integer number from here, and so on. We know. So you don't need to tell other people what is Z, what is N, because that is built in already for our Z schema. So you can simply use it. Okay, you can simply use it with your Z schema later. So built in, so Z and N only. No Q, no R, whatever. Don't use others except Z and N only. Okay, basic type. Okay, basic type is the popular type that you are going to represent your data later. So basic type is to represent normally string data. String data, for example, customer name, customer ID, customer IC, customer address. For example, address, maybe email address, whatever. Okay, so those are string data. Okay, string data. So how to represent string data? We are going to use basic type. Okay, basic type. So in our Z schema, to represent basic type, we are going to use square bracket, opening, closing, square bracket. Okay, square bracket. Okay, this is global, means that when one of you, when you do assignment, one of you say name, others also want to use name, no need to do again name, because it's global, means name can be shared among all your team members. ID, you say ID, all want to use ID, can be shared all by your team members. Email, want to share all among your team members. No need to duplicate. Email here, email here, email here, no need. Okay, it's global for everyone. So you just define one time, everyone can use it. Okay, so it is global. But of course, for basic type, there are a few guidelines that you have to do. Okay, the first one is you have to use all capital letters. All capital letters. Okay, that is one of the guidelines that you have to remember. You have to use all capital letters. No digit, no symbol, underscore, whatever, no. No space. Okay, cannot. Cannot have digit, cannot have space, cannot have symbols, and so on. Cannot. Okay, and another one that you have to remember, it must be singular word. It must be singular word. You cannot have names with S. You cannot have emails with S. Cannot. It must be singular word. Okay, all capital letter, singular word, cannot have digit, cannot have underscore, cannot have symbols like dollar sign, whatever, cannot. Okay, if let's say you want to combine two words together, let's say you want to have student name, two words, right? So combine that without having underscore, whatever, both using capital letter, both words are actually singular word. Okay, so if you want to combine two words together. Okay, so that is for basic type. So for example, name. Okay, capital letter, you put inside square bracket. Okay, then person. If let's say you have for your module, for example, for your module, you want to have your own basic type, you can put comma like this. But my suggestion later for the assignment, you will see that I will suggest you to do one by one, because you are going to write description for it. Okay, so but you can do like this. You can put comma in between. Something like two words, you can do like this. But all the words here must be singular word. You cannot have S or whatever. Okay, singular word. Okay, so that is basic type. Normally we use to represent string data. Okay, string data. Okay. Free type. Okay. Free type, normally you want to show something like one specific data at one time. For example, on or off. Okay. Let's say you want to show in your system, you have admin, you have, let's say in our college, in our university, right? We have staff, admin staff, we have lecturer, we have students. Maybe also you want to say, we have the dean, we have the president. So you want to show the job title for each, then you can use free type. Okay, you can use free type. So free type is actually to use something like each, either one per time only. So either this or this or this only. You cannot have two at same thing. If on means on, you cannot on off together. Cannot. So it's either one. Okay. So it's like a choice. Something like you learn something like switch statement in your programming. Switch statement, right? Either this or this or this or this. You cannot have a lot of things there. So either one. So if you have this kind of scenario, then you use what we call as free type. Okay, so the symbol that you are going to use is these two symbols. One is branch separator, another one is this type definition symbol. So, how to write? So you are going to have one variable here. Not variable, it's not variable, it's like one to represent the free type. Okay, the way to write here, I will suggest you to put similar like basic type just now, capital letter, but without the square bracket. Okay, without the square bracket. So, but after that, this is your choices. This is your choices. Okay, so you put colon, equal, then you have choices separated by branch separator. Okay, separated by branch separator. Okay, so all these, for example, off, on. So you separate it by branch separator. So whatever that you have here, my suggestion is, okay, remember what you have to put inside the choices here. Okay, you use similar like variable letter. So how to know that is variable? So you have to use, if let's say one word only, if you use one word only, use all small letter. Okay, if you have one word only, all small letter. If you have two words, let's say two words combined together, the second word I will suggest use capital letter, start with capital letter. Okay, but if you want to go for underscore, because this one can use underscore, if you want to use underscore for your choices here, okay, I will suggest you to put underscore. So for example, let's say I have position. Okay, let's say I have admin. I want to do staff. I will do like this. Okay, and I have position lecturer. Then I have another bar. So, or you can have, then the rest or you can have, if you want to use underscore, rather than you have this, then you put underscore, you can use either capital letter or small letter like that. Okay, so you can use underscore. Okay, so this word here, if you use one word only, all small letter. But if you combine two words together, my suggestion is second word is start with capital letter, or you can use underscore like this. It's either one. Okay, it's either one. You can use digit, but digit will be normally at the last one. Like academic start one, academic, but normally we try not to put number. Okay, in front. Okay, but I know some of you feel that ask me rating, right? 1, 2, 3, 4, 5. So normally my suggestion is don't put rating 1, 2, 3, 4, 5. Put like star 1, star 2, something like that. Okay? Because normally we don't put number 1, 2, 3, 4, 5 like that. We put, for example, you have rating, right? Okay. My suggestion is you put lah star 1 something like that lah. Star 2 and so on. Rather than you put 1, 2, 3, 4, 5. I know I do understand it should be 1, 2, 3 because if you click 1 or 2 or 3 star something like that. Okay. But you can have something like this for your workflow. Okay. So this is actually for the free type. Okay. So for free type here, you separated using bar. Okay, you separated using bar. So normally use one is to declare like choices like this, or later for the error handling. Okay, for the error message you are going to use like this also. Okay, so this is free type. So you have 3 types just now: built-in, basic type, and free type. Okay. So identifier your variable, because you have the type, you have to identify your variable or identifiers. So the identifiers, there are rules or guidelines to do or to create identifiers. Of course, capital letter and small letter will be 2 different things. Okay, so you can use letter, you can use digit, and you can use underscore for identifiers. Okay, but you can, in Z schema we don't put length restriction, so you can put as long as you want. But my suggestion, don't put too long. Later you want to repeat how many times you call the variable. So don't put too long variable, and then don't put too short A, B, C like that. Confused for you later. Also confused for me later. Put a very good identifier name, not too long, not too short. Okay, so the rules is if you have one word only must be small letter. Okay, must be small letter. If you have 2 words, you can combine together. Second word start with capital letter, same as just now, same as your choices for free type just now. Okay, second word start with capital letter. You can have plural or singular, no problem for variable. It's not a compulsory for you to use singular. It can be plural, it can be singular, it's up to you. Okay. And then if you want to use digit, cannot start with digit. You cannot start 1 star, 2 star, cannot. You have to put star 1, star 2, star 3. Okay? You can put in the middle, but I think seldom lah we put in the middle the number lah. We put in front or you put at the back. But you can put in the middle, no problem. Just that I think seldom you put number in the middle. Okay? You cannot put in front. And then also you can use underscore like just now. Admin underscore staff. You can do that. Okay? So you can do that, whichever. But you cannot use other symbol like $sign lah, percentage, whatever, cannot. Okay? So that is a normal like identifier like our programming lah. So, but if you use capital letter, this one small letter, 2 different things already. Okay? So that is identifier. So this is example of identifier that you can have valid and invalid identifier here. Okay. So the next one is related to identifier. Even though we say there are a few symbols or like $sign and so on cannot be used with the identifier, but there is 3 symbols can be used with identifier. We call this as a decoration. Okay, decoration, type decoration. So this is a special case symbol where you use this to indicate something in your schema. Okay, if you use prime symbol, apostrophe, prime symbol or apostrophe, this is to show there is an update variable. You want to show variable, updated variable in your schema. Updated variable, the prime variable will show updated variable. Okay, but if the variable is together with question mark, no space, don't put space, it's together, but not in front, is the last, you put at the last one. So this one is to show input variable, means that you want the user to enter the data, your variable must be with question mark. Okay, when we see question mark, we know that this variable is an input variable. Okay. If you have exclamation mark, this is an output variable. So for example, some of you say, display the information on the screen. How to display the information? Using exclamation mark variable. When you use exclamation mark variable, meaning that the data will be shown to the user. Okay, so these three symbols is a special symbol used with our identifier to show something else. Okay, other than it cannot. So prime or apostrophe, this is to show the update or that the variable after that, variable after we call as variable after. And then the question mark is to show input variable, and then the exclamation mark is to show the output variable. Okay, so how are you going to see this? So you just know space. When you have question mark, student question mark, I know that this variable is an input variable. You can have student question mark, you can have student exclamation mark inside the same place, because this one question mark means input, exclamation mark means output. Okay, so I can have student question mark, student exclamation mark, student prime together inside my system there. So it doesn't matter because the symbol will show differently. Okay, you can use the same variable name there, no problem. Okay, just that don't get confused. You want to show output but you use input variable, then wrong already. So you have to know that question mark is for input, exclamation mark is for the output, and prime or apostrophe is for the change or update after that. Okay, so these three are important variable. You are going to use a lot also in your Z schema later. Okay, so these three symbols we call as type decoration. It's like decorate your variable but with meaning. Okay, with meaning of what you have to use in your Z schema later. Okay, so that is type decoration. Okay, so now how are you going to declare your variable? Okay, you have learned about type just now. You have built-in type, you have the free type, and you have also basic type. Let's say you have done all the type there. You know what you want. Then you also know what are the variables that you are going to use. Then how to declare inside your Z schema later. Okay, so when you want to declare, it's a combination of your identifier and the type. Okay, so how to declare? You use identifier, colon, and your type here. Yeah, colon and your type here. So if let's say this one means I have a student one identifier of type student. I have only one student here. This one means one student. If you want to have many students, you put student, colon, power set student. If you want to have many students. Okay? So this one means that I will have two books, book 1 and book 2 of type book. What book 1, book 2 of type book means one book for book 1, one book for book 2 of type book. One only. Single. Okay, single. I have a person, chain, I have a student name of type name. So the way to declare your variable is you must have colon, okay, in between. So one more thing, at the end of here, actually when you go for Z schema, okay, we will see that even though we didn't put semicolon, originally semicolon will exist in your system. Okay, but no need to put semicolon for your declaration. So for example here, I have three just now. I have a type just now. Let's say I declare name, ID of string, basic type. This is basic type. So for your assignment, why I say rather that you put comma and so on, your assignment, my suggestion is for you to declare your type like this, where you put a declaration of the type there. For example, name, I will put the set of all staff name in the system, for example. Okay, then you know what you want to do inside that. So list one by one inside your assignment later, whatever the data type that you want, and then you put the set of all, the set of whatever lah. Then you put declaration like this. So in this case, I have two basic type, name and ID. So name is the set of all staff name in the system, whereas ID is the set of all staff ID in the system. Then you may have other things, then you just list all the basic type together. Okay, so now I have a position here of a free type. Okay, free type. So colon equal. Remember, position here free type. Don't put square bracket because this is not basic type. Okay, square bracket only for the basic type. Okay, so this one without square bracket. But I have colon equal. Okay, then I have branch separator, meaning that the position of my staff, either admin or staff or customer, for example, is either one. You cannot have two at the same time. So either one only. Okay, it's like gender. Let's say you want to check the gender, female or male. Okay, don't put others also lah. In Malaysia, we are not accepting others. So put female or male only for gender, for your system. So you can use free type. Okay, so you can use free type to represent. Okay, then how to declare? You put name of type. Name means that my name here, this is my variable, colon name. Means that the data here, the name will be string data. String data that I will represent in my database. Okay, ID also string data. Okay, position is either admin, staff or customer. Either one only. It's either admin or staff or customer. And then price, let's say, so built-in, I don't need to put here. I don't need to put here because it is built-in. Built-in means I can straight away use in my system. So straight away I can put and like this, built-in. Okay? So this is how you declare individual. Okay. So let's say I want to copy this. Okay, if I say, I want to have many ID. Okay, this is the one just now. So I want to show many. So here, maybe you want to change variable become names, for example. Small letter. Then here, you can put power set to show that you will have many names inside your database. Okay? And same thing for ID. You can have power set of ID. Position. You have many, but for each individual will be one, but you have many position. Same thing, you put power set. Okay, but for price, N or Z, because it is infinite set, even though you have 10 or 20 or 50, you don't put power set. For N and Z, no need power set. So you just remain as N. Okay? So if you want to use power set. Okay? So compare just now one single one only. Here it will be by putting power set, it will indicate many names, many IDs and many positions available in your database. Okay? So and price, even the many, you don't need to put power set. For N and Z, no need power set. Okay? Only for basic type or free type you use with power set. Okay? So this is what you have to remember when you use power set later. Okay. Let me see. Want to go straight or not? Can accept or not?
Cannot.
Yeah, I will add. Hey, wait. This is that schema. How many more slides? Okay, I will finish until this one. A few more slides to go. Then after that. Okay? level already. You know what is basic type, what is free type, and so on. So now, this is actually to tell you how are you going to proceed with your assignment already. Okay. When you are going to do assignment, up to this week you have, let's say you have done all your introduction already, right? All your introduction, your requirements list, everything done. Then the next step is your data abstraction. Data abstraction is your defining your basic type and free type. Okay, basic type and free type. No need to define your built-in because already there. But the process after this next week task is to define your basic type and free type already. Okay, so meaning that the first thing is you go for basic type. Okay, basic type, normally that is the general, you go for basic type. Another terms for basic type, you may have seen also in past year, whatever, the word given set. I forgot to tell you, the word given set is also known for basic type. Okay, sometimes you will see this, so you will have also the word given set. Okay, so you can have also, after your defining your data abstraction later, there is another part as a global also, because data type, free type will be global. Okay, so you can have another global we call as axiomatic definition. So axiomatic definition to show global variable. Okay, for example, let's say you want to say that every class maximum 24. Okay, every tutorial class maximum 24 means that global for everyone in the system, maximum student in the class is 24. So you do using axiomatic definition. There are two symbols. Okay, so I call this symbol as sleeping T lah. Okay, this symbol. This is a special symbol we call as axiomatic definition symbol, where you have T. Okay, sleeping T. On top is declaration, below is predicate. Okay, so this symbol on top, you have every, let's say you have 3 variables, you have to separate to 3 different axiomatic. Let's say one is max style student, one is max room, one is max price, for example. So 3 different things. So you have to have 3 axiomatic definitions. You cannot combine. You cannot combine together. Okay? So declaration, predicate. So for example, declaration like you do declaration just now, max student of type N. So I can put max student equals to 100. Sometimes I'll put max student less or equals to 100. Doesn't matter. But you put your constraint here. Okay? This is a constraint. Condition lah. Condition. This is a condition. Okay? So above is your declaration. Here is the condition. Means that cannot exceed this value. Okay, cannot exceed this value. This is a condition. Global to everyone. But some cases, you don't want to have this constraint. Maybe you want to show different decay room. Decay room. Some room, one decay can have 200. One decay can have 100. Another decay can have 150, for example. But you want to show that it's a fixed number, but there is a max student only number. So you don't want this value, because if you put 100 means every decay will have 100, but you may have different size, right? Different total size. So you can have, okay, axiomatic also, where you have only declaration. You don't have the below part. This is what we call as without constraint. Okay, without constraint, just do like that. So, okay, how to find the symbol? Yeah, how to find the symbol? In your Z tab here, okay, if let's say you go to Z GitHub, there also got. So you will see this is the sleeping T just now. Okay, so you put this, then it will come up like this. So let's say max students. Of type N. Okay, then max students. If you want to use less than or equal, you use this one. Less than or equal 100. Okay. But if you don't want to have this, okay, you choose the below here. This is the one. Not the keyboard, not the keyboard bar. This is the one. Then you put this. Okay, you put this. This statement normally you put after your data abstraction, means after your basic type, after your free type, you go for this one. But this one is not compulsory for everyone to have. It's optional. If you want to have a specific constraint, then you can have axiomatic definition. But in the practical, I will explain again about this. Don't worry. Okay, so normally you will have this thing. So the symbol is this one. These two. Okay, this is the one that you choose for axiomatic definition. Global variable means that if you put here, okay, before everything else, so it is global. Means everyone from your team can use the same thing. Maybe you do this, your friend also want to use Mac Student. You can use inside his or her statement. Okay, because it's global. So you don't need to define another one for her. Unless you have another one. Let's say when you do here, you want to have for example another axiomatic, then you just where is it? I accidentally did it. Let's say I want to have another one. Your friends want to have also axiomatic, then you create another one. Okay? So max, for example, of type Z. Doesn't matter like which one, then you put max equals to 1000. Okay? So you can have a few of axiomatic definition. Okay? So, but each axiomatic definition has to be separated. Cannot be combined together into one. Cannot. It must be separated individually. Okay? So that is the last part lah. So you can do, if normally some people they want to do like equal also can, but I seldom ask you to do like this. This one, let's say you want to have just now right, specific. You can also, rather than you use axiomatic, you do like this. Can. But for me, I will suggest you to go for axiomatic definition. Understand, easier for you to understand. Okay, rather than use this one. Okay, so I think I will end for today. So, how? Next week lecture, how? I will contact your class rep to discuss. Okay, so about this. Okay, so any question before we end our class today?